All right, good morning. I am going to quickly review how to solve equations. During this semester, we kind of came up with a list of 5 questions, statements that we used as you solved equations, and you guys did awesome. So I'm going to just go over that and do 3 problems, and hopefully that's enough. As with the other videos, if you want to try the problem on your own, try it and then pause the video, then you can check your answer. If you would rather watch me do it, that's fine. You can do this however makes you comfortable. Just use it for your advantage. So, to solve equations, the questions that we chose to ask ourselves were, first, can I distribute? Can I combine like terms? Add or subtract something? Move all of the x's or variables together on the same side of the equal sign by adding or subtracting? And divide if you can. While these aren't like the full every situation questions, they work for every problem that we have solved. So I hope that this makes you be like, oh, I remember her saying that. All right. So then we realized one day that there were 3 different kinds of answers you could get. You could get one solution where x, or the variable, equals a number, like x equals 4 or something like that. You could get no solution, and that kind of happened at the end if you ended up with 0 equals 5 or some kind of thing that doesn't make sense once you get down to the end. Because these are not the same, this has no solution. That equation doesn't work. And then infinite solutions at the end ended up being something that made perfect sense, but you either had no variables or you had something like x equals x. In those cases, it has infinite solutions because no matter what number you substitute in for x, you're going to get the same answer as a result. So hopefully that makes you be like, oh, I miss math so much. I remember when we learned that. And if not, hopefully these next 3 examples will. All right, so we're going to start with number 1, and in our class, we always drew a line straight down through the equal sign just so we could keep track of all of our stuff. And then we went through the questions. We covered up one side and we looked at the other side. Can I distribute? Well, yeah, we can distribute on this problem. We can distribute this 2 to the x and to the 3. We cannot go beyond that because the parenthesis ended. All right, so let's do it. 2 times x is 2x. 2 times 3 is 6. And we still have the negative 3x that was there, and this side stays the same. Okay? We also would cover up and say, can I distribute on that side? No, we can't. So we are now done with step 1. All the distributing is done. So now we need to combine like terms. Can I combine like terms on this side? Yes, we have 2x and negative 3x. 2 minus 3 is negative 1x, and we have our positive 6 still over there. Can I combine like terms over here? No, there's nothing with like terms, so we still have negative 2x plus 10. All right, we are done with combining like terms, and so we're going to move to step 3. Add or subtract something. Remember, at this point, you have a lot of freedom. There are 4 things you could choose to do. You could add x, subtract 6, add 2x, or subtract 10. I'm just going to choose to add, I don't know, we'll add 2x. Negative 2x plus 2x cancels out. Negative 1x plus 2x is positive 1x. And this is the stuff that's left. All right, so now it says move all of the variables together. Well, we already did that, so we're going to add or subtract something else. We want to get all of the numbers away from the variable, so we're going to subtract 6 because that was on the same side, and that will cancel. So x equals 4. And the last step says divide if you can. We have no need to divide here because 1 is right here, x is alone, and this one's finished. This is an example of solving an equation that has one solution. All right. Hopefully that makes you remember. And let's look at number 2. We're going to draw our line straight down through the equal sign, and we're going to go through the questions. Can I distribute? Yes, I can distribute 2 to x and to 5, not to 6x because that's outside of the parentheses. So that gives us 2x plus 10 plus 6x equals, can I distribute? Yes. 2 times 4x is 8x. 2 times 5 is 10. All right, distributing is done. Let's look at the next thing. Can I combine like terms? Yes, 2x and 6x. That's 8x. All right, add or subtract something. So I'm going to choose to subtract 10 from that side and this side. That cancels off there. So on this side we have 8x equals 8x. And hey, that canceled there too. So right now we have 8x equals 8x. At this point, you could be like, oh, those are exactly the same. This has infinite solutions. Or we can continue with the problem. We want to move all of the variables together. So we could subtract 8x from this side to move that. That gives us 0. And then we have to do the same to this side, subtract 8x, which also gives us 0. Since 0 equals 0, this has infinite solutions. That's the answer. Any value will work and make this equation true. All right, one more quick example, and then you should go practice. Okay, move the paper a little bit. All right, for this example, I wrote it a little bit differently just to kind of talk about what would happen in this case. We're still going to go through the questions. Can I distribute on that side? No. Can I distribute on this side? No, not really. There's not really a thing with parentheses, but we do have a denominator that we don't want. And hopefully you remember from class, to cancel out denominators, we multiply by the denominator. So we need to do that on both sides. On this side, it cancels out. But remember, on this side, we're multiplying the entire side by the denominator. So you do need to put the parentheses. And now that's the distributive property. So we're going to distribute over there. 3x plus 6 equals 3x plus 7. All right, add or subtract something. So I'm going to subtract 6 this time. Remember, there were 4 things you could do. That cancels. So 3x equals 3x plus 1. All right, move all variables together by adding or subtracting. So we're going to take the 3x off of this side, so we have just the constant over there. And we're all going to do the same to that side. So now we have 0 equals 1. Well, that doesn't make sense. When you get an answer like that, the answer is no solution. Nothing works. There's no number that you could substitute in for x that would make this equation true. All right, I hope that was a good little review, and have a great day.